we'll go to this page. We talked about alpha, which is the significance level. And then I did mention that it is hard to justify the choice of alphas. So usually it is even set before the research is even conducted. We also learned that we reject the null hypothesis if the p-value is less than alpha. What do? We reject the null hypothesis. And then I remember in chapter 18, when we were dealing with the p-value and then we were concluding that the p-value was large or small, we were using an alpha level of what? 0.05. But like I did say, the alpha level can also be 0.1, it can be 0.01, 0.001. So usually it can be specified. But if it's not specified, then you can use 0.05. That was what we did in chapter 18. And then also know that the alpha level is also called the significance level or level of significance. Last time we were able to finish question 7. So today let's try to finish question 1 and 2 from the chapter 19 homework problems. So open to chapter 19 homework problems. Let's attempt question 1 and 2. So let's start with question 1 first. So question 1, it says that which of the following are true? And then if it is false, you should briefly explain why. So we are going to do A, B, C, and then D. A very high p-value is a strong evidence that the null hypothesis is false. We know this is incorrect because we know that when the p-value is low, that is when the null hypothesis is rejected. Is that okay? So it's not when the p-value is high. Is that clear? So that statement is easily seen to be false because we know that it is a low p-value. That is a strong evidence that the null hypothesis is false. So the statement is false because it is a low p-value that provides the evidence that the null hypothesis is false. Let's get to B. B says that a very low p-value proves that the null hypothesis is false. Now, we are not proving the null hypothesis here. A very low p-value only tells us that there is a strong evidence that the null hypothesis is false. It does not prove. Is that okay? That is why we are doing this chapter, because we can make mistakes. Is that okay? If you are proving something, it means something exists. Does that make sense? So a very low p-value. So this statement is false because a very low p-value only shows strong evidence. Is that okay? So because when p-value is low, we reject the null hypothesis and we conclude that there is a strong evidence. Let's get to C. C says that a high p-value shows that the null hypothesis is true. Well, a high p-value shows that what? We fail to reject the null hypothesis. So when we look at the options here, we can clearly see that A is out, B is also out. So a high p-value, the statement is false because a high p-value shows that the data is consistent with the null hypothesis, but can never prove that the null hypothesis is true. And then let's get to D. D says that a p-value below 0.05 is always, the key word here, always considered sufficient evidence to reject the null hypothesis. Now, what is always considered as sufficient evidence to reject the null hypothesis is if the p-value is always below alpha, not 0.05. Alpha could be 0.05, like we did earlier on. Alpha could be 0.01. Is that okay? So if you want to say always, we shouldn't limit ourselves to only 0.05. Is that okay? How about if alpha is 0.01? If alpha is 0.01 and the p-value is say 0.03, it means that we cannot reject the null hypothesis. Is that okay? So the problem with D is using always for what? 0.05. If you want to use always, the p-value has to be below alpha. Is that okay? So you can see that this statement is false because the null hypothesis is rejected whenever the p-value is below the value of alpha. And alpha may not necessarily be 0.05. We just learned that alpha could be 0.1, could be 0.01, could be 0.001. Now let's get to question 2. Question 2 says that which of the following are true? If false, we should explain briefly. A, using an alpha level of 0.05. So our alpha is 0.05. And then our p-value is 0.01. Is the p-value here low or high? Compared to, they've given me the alpha level. Is the p-value low or high? Low. If it's low, what do? We reject the null hypothesis, isn't it? So results in rejecting the null hypothesis. So what is the right answer here? Yeah. Let's get to B. B says that the alpha level depends on the sample size. So the alpha level, which is 0.05, 0.01, 0.1, or 0.001, does it depend on the sample size? We just learned that what? It does not depend on the sample size, right? And then we also learned that it's even very difficult to even justify a particular choice of what? Alpha. So we can see that the alpha level does not depend on the sample size. So when we look at the options here, we can clearly see that D is out. And so C is the right statement because you can see this statement is false because the alpha level is set independently and does not depend on the sample size. Let's get to C. We have an alpha level of 0.01 and a p-value of 0.06. So I want to ask you, is the p-value high or low compared to the alpha level of 0.01? It's high. If it's high, what do we do? We fail to reject. Is that okay? But here it says that what results in rejecting. So that is false. Is that very clear? Good. So we can see the statement is false. And then let's see. This statement is false because only a p-value less than alpha level results in rejecting the null hypothesis. And then let's do D. We have an alpha level of 0.05 and a p-value of 0.07. Is the p-value low or high compared to the alpha level? Is the p-value low or high? The p-value is 0.07. Alpha level is 0.05. It's high. If it's high, what does it mean? We fail to reject. Is that okay? But here, it says that it means that the null hypothesis is true. Does it mean that? What it means is that what we fail to reject the null hypothesis. So let's see. So we can see that the statement is false because p-value greater than alpha only indicates that there is not enough evidence to reject the null hypothesis. So you can see there is not enough evidence. That means we fail to reject. And that is our conclusion. There is no evidence or there is insufficient evidence. So you see, it's very important to read through carefully. So you see, B is also similar, but B says that it only indicates there is enough evidence to accept. So that is what you just have to be careful. So that is 1 and then 2. We did 7 last time. Now let's get back to our slides. Remember, we are making decisions here. What decisions are we making? We are either rejecting the null hypothesis or we are failing to reject the null hypothesis. Can we make mistakes? Absolutely yes. Is that okay? If the null hypothesis is true and then you reject that, you've made a mistake. Is that okay? If the null hypothesis is false and you fail to reject that, that is also a mistake. The heart of this chapter is the errors. So I'm going to take time to explain very well. So make sure that you understand. If you don't understand, just draw my attention. So like I said, even though, look at how we make the conclusion that there is enough evidence, there is insufficient evidence. And so we could make mistakes. Now, even with lots of evidence, we can still make wrong decisions. And then we can make mistakes in two ways, which I have listed here. That the null hypothesis is true, and then we mistakenly reject that. Or the null hypothesis is false, but instead of us to reject, we failed to reject. Those are the two types of mistakes we can make. And then these types of mistakes have names. They are the type 1 and then the type 2 error, respectively. In your exams and your test, they are going to test you about these two types of errors. So it's very important that you are able to identify one when you see it. Remember, these are the two types of mistakes we can make. And then these types of mistake are type 1 error or type 2 error. What is type 1 error? Type 1 error is what? When we reject the null hypothesis, when in reality it is true. That is type 1 error. So you should take note of that. Type 1 error is when we reject the null hypothesis when it is actually what? True. The good decision, since this is true, we should have failed to reject it, but we rejected it. Is that okay? So that is an error, and that error is what? Type 1. So for example, in a jury trial, type 1 error can occur if the jury convicts an innocent person. If the jury convicts an innocent person, the jury found out that the person in question is guilty, whilst in reality, the person is not guilty. Is that okay? So that is type 1 error. The key thing you have to understand is you should be able to identify type 1 error occurs only when you reject the null hypothesis when in reality it is what? True. Take note of that. And we usually represent type 1 error with same alpha. Like we learned, alpha is a significance level. It is also the probability of making type 1 error. So know that your test 3 is going to list some symbols and ask you what they mean. For example, you could have spoken about this in previous lessons. You could have S, you could have sigma, you could have mu, you could have X bar. Now you could have alpha. Alpha is significance level. It is also the probability of you committing a type 1 error. So you should know that. And then no, type 1 error occurs only if you reject the null hypothesis when it's only true. And then when the p-value is small, you can make this type of error, because if the p-value is small, it's going to make us reject. So the key thing I want you to take note is this. Type 1 error occurs only if you reject the null hypothesis when in reality it is true. The other error is the type 2 error. Type 2 error occurs is when we fail to reject. You see, type 1 error is reject. Type 2 error is when we fail to reject the null hypothesis when the null hypothesis is false. If the null hypothesis is false, we should reject it. But we made a mistake and then we failed to reject that. And so we have committed an error. And that type of error is the type 2 error. So type 2 error can occur in a jury trial if the jury fails to convict a guilty person. Type 2 error is represented by this letter, beta. So when they ask you what is beta, beta is the probability of what? You committing a what? Type 2 error. So you should know what beta stands for. Beta, type 2 error. Alpha, type 1 error, level of significance. So you can see I also went ahead to write here that the probability of making type 2 error, I think here should be 2, is called beta. So I think here should be 2. Probability of making type 2 error is beta. And then type 2 error occurs if the p-value is large. If the p-value is large, it means we are going to fail to reject that. And so we can make this type of error. So I decided to also provide a table here. So these are the decisions. If H naught is true, and then we reject the null hypothesis, it means we have committed a type 1 error. If H naught is false, and then we rejected the null hypothesis. If H naught is false, and then we rejected the null hypothesis, that is a good decision because it is false, and then we ended up rejecting that. So that is a good decision. If H naught is true, and then we fail to reject that, that is also a good decision. But if H naught is false, and then we fail to reject that, that is a what? A type 2 error. So you should take note of that. The other thing we want to talk about is the power of a test. The power of the test is the probability of making the correct decision. Is that okay? The power of the test is the probability of making the correct decision. That's the probability that we succeed in rejecting the false null hypothesis. So the power of a test is giving us 1 minus beta. So you should also have this in your note. Power of the test is 1 minus beta. So 1 minus the probability of what? Committing a type 2 error. So if we want the power of the test to be high, it means that our chance of committing a type 2 error should be low. Is that okay? Good. So to increase the power of the test, that is our focus. We always want to make the right decision. We must increase the sample size for a given alpha level. And then also, if we try to reduce the type 1 error, it moves the rejection region further out in the tail, which would increase the probability of what? Type 2 error. And then correspondingly, it's going to what? If the probability of type 2 error increases, it's going to reduce the power of the test. So in summary, you should be able to ask yourself, if you see a problem, the first thing you need to ask yourself is, did they make a mistake? If yes, what mistake did they make? Did they make a type 1 error or a type 2 error? So let's try to test our understanding on chapter 19 homework. Let's do question 6 and then 5. So open to chapter 19. Let's do question 6 and 5. Let's start with question 6 first. So question 6, it says, for each of the following situations, you should state whether type 1 error, whether a type 1, a type 2, or neither error has been made. Okay? So we've been given the situations from A to D. Is that okay? And then you have to ask yourself whether they've made an error based on the details they are going to provide. So let's start with A. A, what is the null hypothesis? Mu equals 20. Is that okay? The alternative is the mean greater than 20. Is that okay? This is the null hypothesis. This is the alternative hypothesis. Is that okay? What is their decision? They decided to reject the null hypothesis. Is that okay? What did they do? They reject. So if you reject the null hypothesis, it means that there is sufficient evidence that the mean is greater than 20. That is what they are saying. Are we all good on that? So this is their decision. But later, they discovered that the mean is 19.9. This mean is not greater than 20. Is that okay? But this is the decision they made. Did they make an error or no? Do you all agree they made an error? Are we all good on that? They made an error. Okay. Now we have two types of error, type 1 and type 2. So what did they do here? They rejected the null hypothesis. Whilst in reality, they shouldn't have what? Rejected that. Is that okay? So what type of error did they make? Type 1. Do you all agree to that? So they made a type 1 error, which is good. So since she has been able to see it's a type 1 error, you just have to come through your possible answers here. And then it means you are battling between A and C. Do you all agree with that? It's multiple choice. You have to be smart about what you don't have to read everything. The moment you begin to read everything, they could confuse you. Is that okay? So now she says type 1, which we all agree with that. Now it means that we are battling within A and C. So what is the correct answer? Should have not been rejected, right? So it's C. Now let's get to B. B, this is hypothesis for proportion, right? P is 0.4. Is that okay? And the alternative is P less than 0.4. What did they do? They failed to reject the null hypothesis. Is that okay? So since they failed to reject the null hypothesis, it means that they do not have enough evidence that the proportion is less than 0.4. That is what it means. Is that okay? So later they discovered that P is equal to 0.5. Now tell me, did they make a mistake or no? Anybody want to try? Do you want me to mention names? They failed to reject the null hypothesis. Is that okay? So they are saying that P is not less than 0.4. In technicality, that's what they mean. Is that okay? And then P is 0.5. Were they right or they were wrong? Right. Is that okay? If they had rejected, it means that they are saying P is less than 0.4. So then P is 0.5, they made a mistake. Is that okay? But here they did not what? Reject. They failed to reject and later discovered that P is 0.5. The alternative is saying P is less than 0.4. But here is P is what? 0.5. So, and then they failed to reject. So they made a good decision. So It means that the answer is between A and then E. What do you think is the correct answer? So it was rightfully not rejected. Let's get to C. The null hypothesis is 0.5. Alternative is not equal to 0.5, which means that it could be anything except 0.5. Is that okay? What did they do? They rejected the null hypothesis. Is that okay? So in reality, it means that they have sufficient evidence to say that the proportion is not 0.5. Is that okay? That is what it means. Now, later, they discovered the proportion is what? 0.65. Did they make a mistake or no? They didn't make a mistake. Is that okay? Because they said that the proportion is not zero point 0.5 and relative it was not 0.5. So it means that the answer is between B and D. What do you think is the right answer? So no error occurred because the null hypothesis was rightfully rejected. Is that okay? And then let's get to D. So for D, we have the proportion to be 0.6. And then the alternative is less than 0.6. Okay? What happened? They failed to reject the null hypothesis. Is that okay? And then they realized that the proportion is 0.5. Did they make a mistake or no? They made a mistake. Is that okay? They should have rejected because this 0.5 is what? Less than 0.6. So they make a mistake. What mistake did they do? Type 1 or type 2? Type 2, because it's type 2 that when that type 2 that's it's only when you fail to reject the null hypothesis when it is what? False. Is that okay? So fails to reject null hypothesis when the null hypothesis is false, that is what? Type 2. So they made a type 2 error. So it means that the answer is between B and then D. So what is the right answer? B or D? B. Because type 2 error, because the null hypothesis should have been rejected. Now let's get to 6. Oh, I think we've done 6. We just finished 6, right? Okay, so we've done 5 and 6. Okay, now let's get back to our slides then. So you see, this is not difficult. It just requires you to understand them. So you see how I was able to solve them. I first look at what I was given, the decision they made. Then I ask myself, did they make the right choice or no? If yes, okay. If no, what type of error did they make? Is that okay? If they rejected, instead of them failing, they should have failed to reject. If they rejected, then I know that is type 1. If they fail to reject and it's an error, I know that is type 2. Is that okay? So you should be able to see that. The other thing we want to talk about is using confidence interval to conduct hypothesis testing. So this is similar to what we did in chapter 18 homework question 15. So if you are given a confidence interval, all you have to check is that is is the proportion within the confidence interval. If it's outside, then what? If the proportion falls outside the confidence interval, what do? You reject the null hypothesis. Is that okay? That is for two-sided tests and the same thing. Now, we will do chapter 19 homework soon, question 9. But before that, I want to talk about binomial distribution. So binomial distribution, it's a probability distribution that models the number of what? Successes in a fixed number of what? Trials. So we use binomial distributions when we want to model the number of successes. It's usually used in situations where there are only two outcomes. Either you succeed or you fail. Is that okay? So for example, to implement binomial distribution, the trials has to be independent, and then each trial has to have two outcomes, success or failure. It's like tossing a coin, head or tail. Is that okay? Those two situations. And then we use P to denote the probability of what? Success. And then this is the binomial probability distribution. You don't have to worry much about this because for you, your responsibility is to be able to find out what N is. N is the number of what? Trials. What X is? X is the number of what? Successes. What P is? P is the probability of success. And StatCrunch will do everything for you. Is that okay? So let's use StatCrunch to do this. So we have that what is the probability that fewer than 6 shots? We are looking at the probability that what? X is less than what? 6. Made by 70% free throw shooter. So it means that P is 0.70. Who takes 10 shots? Our N is 10. That's all. So to be able to do this on StatCrunch, let's open StatCrunch. Your responsibility is to be able to know P, know N, and know X. One trick, X, number of successes cannot exceed the number of trials. Is that okay? Does that make sense? Good. So you can't say you should always just know that. So now let's try to, we are going to look for, now you should be able to, I did less than 6 because it says that what? Fewer than 6 shots. That is why it is less than. Does that make sense? If it says more than 6 shots, that is what? Greater than. At least 6 shots greater than or equal to. Is that okay? Okay. So now let's open to StatCrunch and do this in StatCrunch. You realize it's very easy to do it in StatCrunch. So let's do this in StatCrunch. And then, okay, so we have StatCrunch here. So to do the binomial, you'd have to go to Stats, Calculators, Binomial. Stats, Calculators, Binomial. Is that okay? Stats, Calculators, Binomial. You click on that. All you have to do is what? What is N? The N is 10. Is that okay? What is our P? 0.7. You change that. We are looking for what? You have to change. Look at this. We are looking for X less than, not less than or equal to. Is that okay? Fewer than 6 shots. We change this to be 6. Is that okay? And then we just hit compute and it does that for us. So that is the what? The probability. Now, let's move to chapter 19, homework question 9. Let's go to chapter 19, homework question 9. The one about the confidence interval. So we have chapter 19. Let's go to question 9. Okay. So it says that in a poll, the president's approval rating stood at 55% in a daily tracking poll of 1,200 surveyed results. We should find the 95% confidence interval. We know how to do this. We've talked about this in chapter 18 and I think 17 or so when we are dealing with the proportion. So let's try to do this in Start Crunch. We'll just go to Start Crunch, go to Stats, and go to Proportion Stats, one sample with summary. Proportion proportion stats, one sample with summary. We click on that. Is that okay? In my, I don't know for yours, but for mine, N is 1,200. Is that okay? So I put that here. What is the number of successes? To find the number of successes, multiply 55% by 1,200. And in the earlier class, one student showed us a trick. Just do 0.55 here and do times 200. Or for me, I prefer to use my calculator to do that. Is that okay? I'll just do 0.55 times 1,200, not 200. It should be 1,200. I got 660. So I won't do this here. I'd rather put 660 here. Is that okay? That is what I'm going to do. But then if you don't have calculator, you could do that. I think that is also a smart way to do that. What do we want? Confidence interval. I want the confidence interval for 95%. So that is what I'm going to do. So it's already 95 here. Okay. If yours is 90, you just have to change it to 0.9. Is that okay? And then I hit compute. So the lower is what? 0.5218. My upper is 0.5781. So I just need to put them here to 3 decimal places. 0.522, 0.578. You see? Good. And then the question is saying here is that based on this confidence interval, okay, test the null hypothesis that the president's approval rating was essentially the same as his approval rating of 50%. So when he was elected to his second term. So you just have to ask yourself, is this 0.5 within this interval? No. Is that okay? Because the lowest here is what? 0.522. So since this is not within this interval, what do? We reject. Is that okay? Good. Because the approval rating of what? 50% is not in the confidence interval. Does that make sense? And then we click on this one here. Good. And so Friday, we would be doing chapter 20. I think chapter 20 should be the last topic we are going to cover. I'm hoping we finish that by Monday. We will do reviews for exam 3. And then after exam 3, we will be doing reviews for the final exam. I will encourage you to put in your maximum best so that you can improve your grades, or you can whatever score you want to get, you can be able to achieve that. And I'll be taking attendances till the last day of class. So just know that. I'll see you guys on Friday. Have a great day. Yeah.